I don't really have many updates. I'm just working on what we discussed on Friday. But I did want to ask if we could go through the methods document.
No, I didn't.
Huh? No. I'm saying, can we go through it now together?
Okay, absolutely.
That way we can
So,
I can go ahead and submit it for us.
absolutely.
Yeah, it's like weird because I really still don't understand why they want us to do that, but because it's not like things change much, but let's see. Let me pull it up so I have it. Share my screen. Okay. So what I have been doing is basically just updating this column, the status column. Let me see, actually, hold on. This one. Okay. No, this is updated. Okay. So maybe we can just go through and see if anything has changed, and then I'll apply this for both 9 through 12. I'll just put one document for all 3 weeks.
Okay.
Um,
Can you go to the first one? Okay, action. Collect, organize, collect from Xenophont. You can also for the action adapt. We are collecting data from
iNaturalist.
iNaturalist. Yes.
Yep.
Okay. So done. The next one, noise reduction. So basically we might not do the noise reduction, but we do the quite the opposite. So we are going to train the data adding up real world noise like background. So in this case, add up use audio augmentation.
Okay.
Yeah, as a second. It's okay, just don't delete it because just adapt the next clause. Yeah, audio augmentation. Audio, yes, audio augmentation to apply augmentation to
To train the model?
uh, not train the model. That's not about training the model. It's about like um mm, to generalize machine to generalize and improve robustness of the model. Okay. And it's not pending, it's like we're doing. Yes, actually doing. Yeah,
Yeah,
like
pending. Yeah.
pending. Yes. But actually, I actually already coded, so I'm just basically waiting for our Xenocanta and Naturalist files, like
Yeah.
the ones like
Yeah, manually.
you're going to upload in the on the folder, and that's it. So basically, yes, waiting on labeled, yes, on okay, annotated or labeled data, not
On
on waiting on annotated or
oh,
labeled. I mean, is the same meaning.
yeah. Okay.
Data. Okay. So the next one, labeling data, manually label data for binary classification purposes. So in this case, manual data for binary classification purposes, and in this case, we are talking only about Hume's Hume's data. Why?
Yeah.
Because like basically today I'm working on the doing so like in our case what's the main approach? I mean like the option A for our task. So first model we identifying like the binary, right? We're identifying the Hume's sounds and other sounds. And when we identify the Hume sounds, sorry, so we run the next binary model. Uh, so like in Hume sound, we identify whether it's a bus or a call.
Right.
So, and in this case, like we manually labeling only Hume sounds, only
Yeah.
Hume's audio sets. But for the others, and I'm going to explain you later on, we are trying to do mm, not automated, but actually, yeah, you can say automated labeling, but it's not labeling, like clustering and labeling. Yeah, so you can do that.
Okay.
Um, uh,
Well, this is the manual one. Should we do maybe?
I mean, that's the, no, it's gotta be this here, like
Okay.
in the in labeling data, because like one piece of one part of the information is manually labeled, and another one it is clustered,
Yeah.
and by clustering we mean that we are splitting the data, the audio data, into clusters or classes. Like so like it's automatically cluster no other bird species that yeah perfect yes actually not other bird species but let's say um soundscape data
Yeah. Yeah, I like that.
cluster and then in parentheses labeling automatic clustering yes. Okay, perfect. So in this case, it is we are working on it. Yeah, so we're working on done for okay, and working on uh soundscape data. So it's not pending. We are working.
Yeah.
Yeah, you can just delete pending.
Well, I just put pending for anything that's in
That is not
progress.
done. Perfect. Yeah,
Yeah.
gotcha. Okay, can we go down? So this one we started. I actually started, and I'm going to show you. Yes, started. Yeah, pending. And actually use pre-extracted features from BERT. No, that's the plan B, but actually okay. Exploratory data analysis. In this case, we are what we have to do. We have to identify the probability of right. Well, let's see. Let me put it in this way: the probability of right classification for each confidence level. I mean, you can put you can reward my sentence to sound better. So like basically we're asking Pranav, right, to provide us his domain's opinion, like not opinion, actually like feedback on how accurate is data, right? So
Yeah.
we are going to provide him like with the random data from based on different confidence levels. So we have to put it down here. Yeah, just and actually exploratory data analysis. We've done a lot.
Yeah.
We let's say we identified a confidence level of zero 0.8, 0.85 uh as the let's say possibly best trade-off. No, that's not. It's possibly the best level to work with based on a rapid drop of genuine data after 0.8.
The best. Mm,
So I mean, just you can reward because
yeah. No, I'm also
just
trying to think.
yeah.
Best way to put it.
And let's do 0.8, 0.85, like 0.8 dash 0.85. So just now like we giving ourselves a range. Actually, okay, yeah, that's good. Based on significant drop in genuine data. Perfect.
Yeah.
Okay, so data structuring. Generate a CSV file containing metadata. Yeah, perfect. Yeah, okay, cool. Preprocess, yes. So we started that. So just yeah, so we started pending. Okay. Yeah, scroll down. Baseline, implement the verb in baseline and preprocessing. You can put it as start. Yeah, pending, it is. Custom CNN, action layers into CNN, not started. Yeah, okay, that's good. That's good. Model training. Define the metrics. Actually, so our metrics, let me put it for you. What will be the metric for us? I'll just put it in chat. So I mean, my suggestion, recommendation. So we have two metrics, and we can discuss it definitely, and we will discuss it because we have to provide the accuracy. So, okay. So, I just put it in our chat what metrics we are going to evaluate, and you just copy paste it.
Yeah, got it.
Oh, wait. Yeah, I define. So, like status done.
We can put it.
So
Yeah.
status done, and in the status, yes, you can, yes, perfect. Yeah.
Yeah, there you go. Good call.
Transfer pre-train models like Burden to Hume's. No, sequential model training. Train Harper, okay. Harper team parameter, okay. Cross validation, yes, not start. Field testing, okay. Okay, yeah, okay, cool. Okay.
Yeah, I don't think any of this.
Data export tools, build tools to export results. Why we didn't start it? I mean, just we already.
Yeah, this is we've started already, right?
Yeah, I mean, and partially is done. Okay.
Yeah,
So
should we say done? Because we built a lot of plots and all that.
yes, absolutely done. Yes. Visualization, yeah, absolutely. We've done a lot of like we provided the full report. The one like I showed in Looker. Yes.
Yeah.
But no the plots in Looker that's the for the next action, visualization of results.
Oh, yeah. Oops.
So you can put it as we provided report and plots for the first part or the first task, and like putting like EDA and analyzing the general data. Several key plots, not just several plots, key plots, because let's say like we ran a lot of plots, right? And then we realized which plots are going to help us make a decision. So that's the key plots. Generated for EDA for okay, generated several key plots have been generated for EDA and yeah, just general data analysis, which is the same actually.
Yeah. And you
Just you can
Looker,
just remove EDA because general data analysis it is the same for yes. On Looker and using library matplotlib.
and what?
And using library matplotlib. I guess that's matplotlib. And mm, which library did you use when you were plotting your charts?
I also use Matplot. Matplot and Seaborn, is that what it's called?
Yes. And just matplotlib and Seaborn. Yeah, Seaborn capital
Oh,
S.
whoops.
Yeah, matplotlib is one word. Okay. Okay, perfect. Yeah.
Okay, cool.
References.
Yeah,
So
this is
actually, for references, I mean, it should be all right because I didn't even have time to check up the references, and in this case, I fully trust what you've got.
well, the references are from
Okay.
when we put the initial methods together. So those aren't going to change or anything.
Okay, perfect.
Okay, cool. I'm going to just save this and then tell them that this is going to be 9 through, what is it, 12 week?
Yeah.
Okay, cool. Let me, here, I'll stop sharing. Method submission.
So, do you have any idea when can you upload the Hume's data, like for
The iNaturalist one?
yes, probably. I mean, like both. Like, do you remember like I created the folders?
Yeah, the data's in there.
Is it okay?
The
Let me
audio
see.
data's in there.
Yeah, like label it like already like 3 second chunks, right?
Yeah, so the 3-second chunks, I'm still going through because I have to manually listen for a buzz and a call for every single one.
Okay, yes,
So it's
right,
just taking
right.
me a little bit of time. Yeah, I finished
Sure.
all of the the date, time, elevation, longitude, latitude stuff. Now I'm just listening for every single one to see. But I could probably have that done by the end of tonight.
Yeah, so like right now, like I would say probably, and I will explain why the top priority is to label and label the bass and song
Okay.
from both Xenocanta and iNaturalist. Why? Because we have to start running the model and we have to get in and we gotta get some results. So we have to see like what's going on. And in this case also, as Pranav is going to India like mm, in 1 week, actually, not in 2 weeks, in 1 week. So we just want to make sure like he's done. He's like he proves that data is correct before he's gone. Because for another part for the high for the random files, right? Like for the
Mhm.
accuracy, like it is important, but not. But in this case, it's not that important for us because if we don't have the data for training the model, we can do nothing. But
Right.
as for his defining the probability, it can just wait like for like I'll say a couple of weeks. Because in
Okay.
our case, we've done everything. We wrote the code, so we just need like actually just okay. They tell us, guys, 0.7 is good. So we just put the confidence 0.7 and we just run the
And then
code.
run
That's it.
everything.
And we
Right.
just
Yeah.
like write down the summary. We look through the data, we see some insights, some patterns, and we just give them the summary and recommendation or anything else. Yes. So
Okay.
that's why the um, Hume's data is top priority. Otherwise, we just can't
Okay.
do anything. Yeah. So in this case, speaking of the priority, let me show you a little bit the code. But I mean, it's still a little bit messy. So I'm just gonna give you the main idea, um, what I'm working for on. Okay, sure. Okay, so basically, let me see. So I'm just putting like some some notes here, like
Mhm.
what we can do, like what can be done, like and why, like the let's say the training data, like that's our focus. But if we do like as a scalable data, so it's gotta be like a little bit different, but it's okay. Sorry. So like in our case, the full pipeline, like high level pipeline, will be as audio input, audio encoder, then windowing in our case it's 3 seconds, then LibRoser and QFormer. I might adapt actually CNN, or maybe RL. So like that's the QFormer is a transformers, CNN is con convolutional neural network, and
Right.
RL is reinforcement learning. So that's basically different algorithms that we can use in our project. So audio embeddings, that's basically for the Q-former only, but we'll see. And the prediction. The prediction, that means how accurate is our data, how good we are at predictions. So like yeah, oh actually I put it here as well. So and basically I have to it up. Okay, just and then reinforcement. Okay. So like in our case, I also put it down. So LibRosa basically and other deep learning algorithms, they work with several formats. And in case of LibRosa, the format of WAV, it is the kind of basic format. So like we have to encode all the formats we have, because we have MP3, MP4, like I know, like FLAC and whatever we have in convert them in WAV format. And
Mm-hmm.
then we also, because like I've just checked out, they have different channels. They could have like 2 channels. The rate could be different. Mostly all of them have 16-bit depth, but mm, we have to also normalize the data for analysis for our model to be like unified. So it's gotta be WAV format. It's gotta be monochannel, sample rate 44.1, and the bit depth 16-bit. So and also like I put it the audio augmentation. Yeah, I'm just explaining like what is for. So like I define some functions. Okay, so the first function is like, so we converting audio files to WAV. Also, we split into, in our case, 3-second chunks, but it can be like any seconds, like any kind of duration. And so I just, let's say I've got a trial data. So I'm just ran the trial data through the all the functions I coded to see like if it's working, and it's working. So like the
Nice.
converting and normalizing the audio, then splitting them in 3 seconds, and I gave you the files. So like, and also like we can check the properties, just like random files. So we can see like if all the files that are in the folder uh, are based on our norms, on our criteria, and we can see like they all unified. Number of channels 1, sample rate 44, 100. That's the depth and the duration. So like, they all the same, and we need this data be unified for everything, for Humes, for others, and also for tests, for training, for everything. So the question was how we can extract the other class. So the data, like the data we need to use as a binary classification when we are defining is it Humes or others. So like, and my idea was we have a lot of data, right? So and
Hmm.
not all of the recording have the Hume's data. So we clean up the data set and we exclude all the recordings that have any kind of Hume's Warbler. And let's say like the recording that do not have the Hume's Warbler, so we are use those recording as a database for the other class.
Okay,
And
I like that. Yeah.
yeah, so and in our case, uh, why the advantage is this data is not gonna be used in testing. So just like we have like our 500 gigabytes of the data, and we kind of splitting them. The data that has Hume's Warbler and doesn't have. So like in this case, like the data that doesn't have Hume's Warbler can be used for the other class as a sound as a yes as as the other class. So like I've just ran the code. So like I created the unique column. So we can identify um, the each row. Um, so like then I created one more column check to see if the row has the Hume's Warbler. And basically,
Okay.
if it has it, then just a value of 1 appears in the check column. If not, then it's a 0. So just like, just I just and then let's say if the recording is recorded in June on June 6th 5 a.m. and we have only one row that is the Hume's. So like this code makes sure that the rest of the rows for this recording are also marked as one.
Oh, I see. Okay.
Yes, and then like we when we marked all the recordings where at least one row has a Hume's, then we just drop them, just drop. That's it. So, and in this case, I put like the zero point 0.5 confidence, but we can play with that. I don't know if we should play with that anyway. So like, and then we have 80,000 rows, 80,000 observations that have no Hume's Warbler at all. But 80,000 rows, that's all the birds. And just I just wanted to get them an idea um, what is the percentage of each bird. So, and we see like
Right.
almost what, like almost 70 per, not 7, yeah, like let's say 60% of the all species are like 3 of them. That's a lot.
Right.
So, and also, so like in this case, yeah. So like, and I wanted to understand how many recordings, unique recordings we have without Hume's Warbler. So just basically you drop in the duplicates and we got like I guess let me see if it's working. Less than like I guess 1,800 something. Oh, okay, it's not right. Anyway, it's gotta be okay. Doesn't matter. So like I save those as a CSV file and like right now, okay, oh my gosh, okay, try again. Okay, so and what I'm doing right now, okay, let me show you. Second.
Give me 1 second. Sorry about that.
No problem. So we have the file. Yeah, so what? We have the file right here. Okay. I guess it's okay. Okay. So, and I'm just going through like every file. I don't know, like, and actually I've done all of them. Maybe I didn't save until, yeah. So, like, let me show you. I created two folders, field data HLW and field data HLW no. So, what does it mean? It means that this data has at least let me show, at least one classification of Hume's Warbler. And in this case, so I'm just like I've just started to do that.
Okay.
And yes, and yeah, this is speech. No. So like you see, like in this case, these recordings, let's say at location PSH2, we have only that much recordings that do not have any Hume's
Anything.
Wilber's
Okay.
classification. So we just put in the data. And this data will be used as the database for our other class.
Okay. Cool. That makes sense. Nice.
Yes.
Okay.
Oh, actually, let me reshare again. So like in here, like I've just explored random bus and call sounds. So like just like the properties, uh, how it sounds.
Oh, nice.
I don't know if you can hear, like just know.
No, I don't think I can hear. I think you have
Yeah,
to.
just a random. Anyway, I
Yeah.
mean, maybe I have to adjust my microphone settings on my audio, but it doesn't matter right now. So like I built some plots. So that's the bus. You see, that's the song. Also the I zoomed in the waveform, so I just
Oh, very cool.
that's the spectrogram. I also
Yeah.
yeah
That I recognize because I've been manually labeling, and typically if it's like a long strand like that, it's
it's a
the
bus.
buzz. Yeah.
It's a
If it's
bus.
like that
Yes,
high
right.
pitched squeaking kind of sound.
Yes, right. So that's the song. So like also the spectrogram of the bus when you put the logarithm on it. Then this is actually one of the most important mm, features of let's
The
say
null
sounds.
frequency.
Yes, that's
Yeah.
MFCCs. We might use them, not might, because like the probability is very high. So just that's how it looks as a plot. Also a chromogram. That's a chromogram, and the chroma. So we can use different let's say pictures, right? Images of the data to make sure like we are capturing as many features as we can. So like let's say if we can get only MFCC, which basically has 13 values, it might not be enough to capture like all the patterns for neural network algorithm. So in this case, we can combine MFCC with spectrogram, with chromogram, or anything else. So and then yeah, just like working on the augmenting the data, yeah, all the stuff. So and that's why I'm just trying to split up like manually right now, split up the data that has Humes and doesn't have. And then I'm going to just run through this data. I'm going to resample and get the third class for us. I mean, that's the second class, but yes.
Okay. Cool. That's very cool. I don't know when you want to share, if you want to share, but I do want to just take a look at the code whenever you. I'm not going to change anything. I just want to look to like better understand.
Yes, I will. I will share. I mean, there is no secret at all. I mean, that's just because like I'm just working on it, and it's not. It's just like like let's say, it's not put it everything in order because like
Yeah.
I'm just like trying like to. I have like some. You cannot call ideas, but some like some problems we have to solve, right? So like
Right.
it's gotta be like in order. But
Hmm.
I'm just like coding like when like I know, okay, we have to solve this, so I'm just coding like just right away, and it just like all like messed up, like the structure. But yeah, definitely.
Okay.
Yeah, so we just need data, and we need to send it to Pranav, SAP, actually, to
Okay.
let him know. And
Yeah, I'll do that
he,
as soon as I can.
yes, and I guess he has the uh, access. Otherwise, if he doesn't, we're gonna share the access to those files, to the folders. Yeah,
Yeah.
I'll check it out.
Okay. Sounds good.
Yeah, that's it so far.
Okay. Awesome. I'm going to upload the methods thing so Isha has that.
Yep.
Um, I'll let you know. I might be able to meet on Thursday. I just didn't want to say I could if I end up not being able to.
Hmm.
But I'll let you know the day of. Friday morning I definitely can't. Or Friday.
Okay, no problem.
But I'll watch the recording after. And I'll send you
Yeah,
any notes I have if we want to bring up for the thing.
yeah, absolutely, absolutely. So yeah,
Okay.
let me know because I
Okay.
just wanted to know just and honestly, I'd love to get this audio for Hume's, let's say not by tonight, but by Wednesday night.
Yeah.
So I'd have some time on Thursday to run the code and at least get some data, at least some,
Yeah.
and then
To
I
show
can
the code.
discuss with Marco and Anand. So and
Yeah.
they give us like some advices.
Okay. Yeah, that sounds good. I can definitely have it done by tomorrow
Yeah,
evening.
yeah. I mean, absolutely yes, because I'm just gonna like work on the code and see like how we can approach the problem.
Yeah. Sounds good. Okay.
Perfect then, and I
Sweet.
hope you feel better.
I do. I feel a lot better. Honestly, I this weekend I really got to rest, so it was good. I finally today I woke up and I don't have any cough or anything, so that was good.
That's good. That's good. That's good. That's perfect. Okay, so if you need any, so just hit me in the chat.
Okay, sounds good.
Perfect.
Cool.
Thank you.
Thanks,
Bye bye.
Andre.
Yeah,
Bye.
thank you.